So, hi everyone. In this video, we will be building our own application layer protocol, just like HTTP, that we'll be using to communicate between two different entities and so on. So, what is basically an application layer protocol? So, all of us know about the TCP IP model that works in networking. So, basically, in the TCP IP model, you have all of these things. You have these four layers: network access layer, network layer, transport, and the application layer. So basically, we are going to build a protocol that would allow us to communicate with the application in the application layer, and further down the line, everything else from the transport layer, network, and network access layer is obviously it's already set up. So we just have to set up an application layer protocol, and which will help us to communicate from one application on one machine to other application on another machine. So basically, what happens is, let's these are the two different entities that are going to communicate with each other. So these are basically two different applications or two different processes that are running. So we just want one of the processes to connect with on to the other processes. So that's what basically our browser does. Whenever you hit onto some API or go onto some website, it's just that the browser connects to the process on that endpoint. So whenever you communicate with the application layer, so let's say you you type in something from here, and let's say you send some data from here to the application layer. The application layer accepts that data in some format that is standardized. So that standardized format, let's say it can be any protocol. It can be a WebSocket protocol or an HTTP protocol or anything of that sort. So these protocols are standardized and they have their own properties that you need to send with them. There are some attributes that you need to send. So if you, let's say, if you have an HTTP protocol, there are different attributes that you'll be sending with it. Maybe you have the request body, then you will be having the authorization headers. Let's say you have headers. In headers, there are many different things. Then you can send content type, which might be JSON or multimedia content type or anything of that sort. So there are many different attributes that an HTTP request has. Well, these are standard attributes defined under the HTTP protocol. For the application layer to communicate with the transport layer, this protocol is something that everybody has signed up to. So if you are signed up to this protocol, you need to follow the rules that this protocol has. So what we'll be doing is we'll try to create our own protocol and let's see how it goes. So firstly, in the application layer, you have these protocols like HTTP and stuff, but what about the transport layer? So whenever the data travels from the application layer to the transport, then to the network access, and then to the network access layer of the other entity, and further up the way to the application layer, and then it is displayed to the user. So the thing that we can do is we need to build something on top of the transport layer. So basically what happens is whenever you send a request from application layer, let's say you send something in this protocol in this format of HTTP, and when you send this, the transport layer does not directly accept it because it has its own protocols. The transport layer has its own protocols of communicating with other layers and dealing with any information that it gets. So down the layer, as you go down the layers, every time the information is going to get divided into certain segments. Let's say in the application layer you have the HTTP protocol as a whole, you have the request as a whole. In the transport layer, as you send it to the transport layer, it will break it down into TCP packets. And once you send it down to the network layer, these packets will be broken down further again. And once you send it to the network access layer, it will be broken down further again, maybe into bits and bytes, which can be transferred physically as well. So this is how basic networking works. And That is why what we are going to do is we don't have to deal with the network and network access layer. We just have to deal with the transport layer. So to create an application protocol of our own, application layer protocol of our own, what we need is we just need to have something uh, on top of this transport layer that we could use. So first we need to access anything from the transport layer. So in the transport layer, the protocol that is being used is the TCP protocol. So what is a TCP protocol? So TCP is basically a transmission control protocol which enables communication, and it's a standard for communication between two different entities. So let's say if you send any data to the any data via TCP protocol directly, obviously that data, there might be some sensitive information as well. Along with that, for to access this data on the application layer, you need to parse this data according to what you have obtained, and for that you will be have to write code on the application layer. So today we don't do that. We just use Express or Spring Boot or anything or any backend stuff of that sort, and once you get the HTTP request, you can simply parse it down into the application. So it actually doesn't worries us or bothers us. So it's just as simple as that. You need to build something that works on top of TCP layer, and you can just access it onto the application layer easily for the developers as well as for users to use it. So in the transport layer, if you see, you will be dealing with TCP packets. So to do this, what we can do firstly is we need to connect these two transport layers. We don't care about what kind of data and how does the data travel through the network as well as the network access layer. So we just have to take care of the fact that we transfer data from this transport layer to the other transport layer, and on the application layer we'll figure out it on our own. So basically what we are going to do in the implementation is that we have this as the, let's say, we need to have a connection between these two layers. So that connection will be provided to us by a TCP socket. So we can write this code in C or C++ where uh, where we connect these two sockets. So we will be having a server and a client socket. The client will create its own socket on certain address. So the server will create its own socket on a certain address, and these two addresses will be same. So the socket will get connected, and a complete socket will be formed. So once this socket is formed, we can send data from one transport layer to the other transport layer. So this is how we will be doing for TCP. Now on top of this TCP, we have to create our own protocol at the application layer. Let's say this is our client, and okay, so what we can do here is that whenever the client sends some data, let's say from the application layer, we will be having a certain format that the client will have to abide by, and the server will also have to abide by. Both the parties will be agreeing on the fact that the format that we are receiving at the application layer will be certain sort. So let's say we have a protocol that we have built on our own, and that protocol is HTTPR, let's say. We have certain rules of HTTPR, we have certain attributes that the HTTPR has to send. So we send all those attributes to the transport layer. At the transport layer, nobody cares about attributes and stuff. It's just simple data. All of these HTTPR data will be converted to some packets and in TCP packets that the transport layer can use and transport it to the other side. So nobody cares about what protocol has been used, what are the different attributes that are being used. So simply the HTTPR protocol will connect to the transport layer. The transport layer will send this via TCP socket to the transport layer of the server. Once once it is received at the server, we can access these packets. Once we access these packets on the application layer, we know that the server has agreed upon the fact that it will be using an HTTPR protocol that is created by us. So the server will parse that data according to the protocol that we are using. And once that data is passed, we can use that data and display it to the user or do whatever you want to do with that data. So this is how basically we are going to go about this. Let's figure out along the way how we will implement this and what all different things we'll be using. So the basic thing that I can see here is that we will have on the application layer, let's say we have a Node.js application that is running, and through this Node.js application, we need to start networking basically. So for that and for TCP sockets, we won't be using Node.js because TCP sockets are a very low level thing, and these are near to the hardware, near to the operating system as well. So for that, for TCP sockets, we will be writing some code in C or C++, which the reason for that is the low level programming language allows us to get access to the system calls of the operating system. So that is why we will be using a low level programming language to create a TCP socket and transfer data through it. Now, how are we going to send the data from application layer to the TCP socket? Like, how are we going to execute the other program? For that, we will be using shell scripting, where we can trigger different programs uh, on the transport layer. In a real world scenario, maybe we can use something like WebAssembly or WebAssembly is this new technology. I mean, it's not new, but it's taking pace nowadays. So it's a type of thing where you can run C or C++ or any low-level language code into a browser. So WebAssembly is a basically a portable binary code format which executes programs of a very low level language into your browser itself. So basically, it's mainly used for high performance stuff, but we can implement this here as well. We can reduce the overhead that is causing because of the shell scripts. If you reduce that overhead, it will really be something that can be implemented in real world scenarios. So currently we'll be using shell scripting, and so let's see how will our code look like and how will the architecture of this be. Yeah, so let's say if we want to create a server, let's say you have to create an Express server. What we do basically is, firstly we import the Express library, then we create an app with we instantiate this Express, and now Express has the capability to provide us with many different functions. Like you have a get function, you have a post function. So what are these functions? These functions enable us to transfer data via HTTP from the application layer into the network or into onto the internet. So this is basically what Express does. Express is a library basically that provides us with many different functions that you can, with the help of which you can send data from application layer or from your application or from the process that you are running on your system to the other process on some other system or on the same system, anything of that sort. So we want to build something like this. So Express actually abstracts out the implementations of how this get and post request works and in what form are we sending this to the transport layer. And this is where we are going to work now. So we have to create some library of this sort, some functions that we will be exposing out to the user. So your users are developers or uh, developers, yeah, let's say developers who will develop browsers on top of this. So we have an Express library that consists of different functions. We also need to create some library of this sort consisting of different functions, let's say, and we can directly connect to these functions from this library. So, and the library under the hood will take care of how it has to create a packet, in what format, how to abide by the format and how to send it to the TCP socket, the transport layer. Okay, so let's see how we can do this. So first of all, we have this as a client, and the client has a process that is running on the system. So this is the application that is running, and using the application layer protocol, we need to send data to the client TCP socket, which further down the line connects the two transport layers. So this application will okay. So let's say the application is running in Node.js, and we send some data. And so if we send a message, that message we will have to send to the TCP socket. So for that, what we can do is we can create a TCP connection with the server, send the message and close the connection as well. So for that, we also will need to have uh, a server here. So this is our server, and on this server as well, we have an application that is running, which we call basically as the backend application, and a TCP socket as well. So, so we need to figure something out so that we can relay the data from these different layers to this application and then also get the response back. So for that, what we can do is firstly, let's say we have an application that is running on Node.js, and Node.js or JavaScript, or on the even if you are working with the browser, you'll be running a JavaScript. So let's say it runs a Node.js and you have a function, let's say send data. So whenever you trigger that function, send data. mm, okay, so let's say you have triggered a function called as send data. Okay, so this function send data will basically get will fetch the data that you have input, or the data that you want to send. It will fetch that data and call uh, call a shell script that consists of the TCP socket code. So in this function, send data, I'll just write down what all things it will do. So firstly, it will take data, convert data to string, let's say, because we will be transferring string overall. It will obviously be in a certain format, but basically, whenever the data transports to through all these layers, it is in the form of string because it is the simplest way you can do that. So in the send data function, you will have to convert data to a string. Once it converts to a string, trigger a shell script that connects to the server TCP socket, and and add the string as argument to the script. So yeah, so this is how we are going to do. We'll trigger a shell script, and the shell script will contain something that will execute the code of TCP socket at the client. And once this is done, we can simply send this data to the TCP socket client function. Now we have another socket at the server side as well. This socket will be up and running by the time we do all of these connections. So this socket server has to be up and running before everything gets started. And once the TCP socket client sends data, you can send the data directly to TCP socket server, once this data is obtained by the TCP socket, so whenever the socket client sends it to the socket server, it will be in the form of TCP packets, which will further down the line go via the network layer and network access layer, break down into bits and bytes, and then L1 is received by the server. So we don't care about that. We just care about the TCP socket that we have formed, and at the server end, we just want it to be in the form of TCP packets. So once we receive this in the form of TCP packets, now we also have to pass this out onto the application layer so that the user can use, so that it is visible to the user. So how will we be doing this? So once you get it at the TCP socket server, this server will also have a shell script that will execute the uh, application file. So the application at the server side is also a Node.js application, let's say, and let's execute this Node.js application as a in the form of a script. So basically, what we can do is we can have the luxury of calling a wrapper function that consists of different methods. Let's say if you have an express, so this express is a wrapper that consists of get, post, and all these methods. So express might be a class or a module that consists of get, post, and all of these things. So obviously we can do the same thing here as well. At the application layer, we can have a wrapper or a class or a module, let's say, and we can call this module over here itself at the TCP socket server level, and that would do for us. But for now, first for that, we might need to have to use WebAssembly or native Node APIs, which can help us execute Node.js into C++ or C++ into Node.js. So for now, what we'll be doing is we'll be creating a shell script. Our main aim is to connect these two sockets, and on top of these sockets, create something that is of our own, a protocol that is of our own, and pass that data according to the way we set rules, and not rely on anything like HTTP or anything of that sort. So once the TCP socket server is executing, it has received data. Now again, it will run it will execute a shell script, and in this shell script, it will call this Node.js application, and the Node.js application will execute. Once the Node.js application executes and returns, the Node.js application will return some string or some data. That string will be taken up by the TCP socket server, sent back to the client, and then the send data function will return the third thing that send data function will do is return response. Fine. So okay. So how can this be done? TCP socket server receives the data. Once it receives the data, I'll just mention something about this. So first is that the TCP socket server receives data. Once it receives data, initiate a shell script that runs Node.js application at the server, get response from the Node.js application, and once you get that response, send the response back to the client, and that's it. So once you send the response back to the client, it will be the send data function will return that response to the application, and the client will receive the response as was requested. So yeah, so this is how the things are going to be once you once the TCP socket server receives data, it will trigger a shell script. Via this shell script, you will the application Node.js Node.js application will run, it will create a response. That response will be sent to the TCP socket server back, and the response that will be sent is will then be taken up and sent to the TCP socket client, and this further will be sent to the client side application, and this is nothing but the value of return value of send data function. Yeah, so this is how the flow is going to be. The name of our protocol is going to be HTTPR, and it will be a very simple protocol. We will not keep a lot of attributes, very simple attributes, and let's figure this out how we will be doing that. So let's see a TCP client server program, and an implementation we will be taking reference from this. So basically for TCP server, what we have to do is create a TCP socket, then bind the socket to server address, and then listen for the client connection. So whenever you create a client, that client when it connects to the server, listen function will execute, and once you listen to it, accept the connection will get established, and now data can be transferred from one entity to the other. So we will be taking reference from here. We will be writing the code in C++, not in C. And once we are done with this, we will have a function that mm, that can execute and connect to the client and server. So first, let's create this server. Let's see if it works. Let's then create a client if that works and modify it according to our needs. Okay, so moving on, let's now start writing the code. First of all, we'll make this TCP server and client so that we are done with the socket programming. And once we get done with this, we can then further move on with Node.js stuff. First of all, we'll write this code and let's see if it works and stuff. So let's start writing that. So I'll have we have to run the server.cpp continuously. We will first execute, run server.cpp, and it will be in the running state all throughout the function, all throughout the process that we'll be doing. So first of all, let's create this file descriptors. So we have a socket file descriptor, a connection file descriptor. Along with that, we also need socket address, uh, socket address structures, server address, and a client address. Let's keep it that way. So what are these file descriptors basically? If you just look at what it is, it's an in the Unix-like computing operating system, a file descriptor is a process unique identifier for a file or input resource such as a pipe or a network socket. So basically, it's an identifier for the socket that we are creating. It's as simple as that. So once we get this file descriptor, we will now create a socket out of it. Okay, so AF underscore INET is the constant that determines what type of address families we will be using. So address family of the type internet, which means it will take up IPv4 addresses. So we have this socket ID now. If now let's also add a null check. Let's set this up. So B0 is a function that sets all the server address bytes to 0. sock addr star of server address and the size of server address. Okay, no, so it is going to be the client address. Sorry, client address. Okay, so here the problem is that the data types are not matching. So plenty client address size equals size of client address. If that should work, client address size. And if I reference to it, yeah, now that works. So now we need the server to wait for any messages that it will be receiving from the client. So for that, what we can do is not wait for messages function. And if that is done, at the end we'll also add the close function. Let's wait for messages. Okay, so let's try compiling this. Okay, so it compiles and let's say if it runs, it is running fine as well. Now we need to write the code for client. I'll just change the we are building these files in the build folder. Now let's write the code for the client. I'll just copy all of these includes and we might need something more. Yeah, so this is the extra one that we need because here we are specifying the address of the client as 127.0.0.1, so that will create a difference. So here also we have the same thing, create a socket and then add the addresses to it and then connect to the socket that we have already created. Okay, so first of all I have to set the fields of the server address. So server address, have I done that here? No, so I have not done that here. That will create a problem. So I'll just add this. So H2NS and H2NL, the functions that we have seen here, these two functions are used to convert the address or any value that we are giving in to a format that can be understood by the network. This occurs when there are different NDNs. When you work on different systems of different architecture, the NDNs of these systems are different. So that is why we are using these functions. These functions will convert the byte, byte value of this variable into a proper NDNS that can be understood by the network. So that is why we are using these functions. Now we'll have to connect to the socket. Okay, so we are done with the client code as well. Let's now test both of these. I'll just compile the client code. Okay, so let's first run the server, running and listening as well. Now let's run the client. It says error in connection. Okay, so the problem was that we have to add a scope resolution operator with this bind function, because bind is not a function that we would be accessing from the standard C++ library. Bind is going to be the system call that we are going to make. So that is why we will be adding a scope resolution operator over here. And now we can see that the we have been connected to the socket. Let's enter a string hi, and yeah, we have sent the message to the server as well as we have received the same message from the server as well. Okay, so all of this is working now. Now we just have to make changes according to our requirements, and here we'll have to execute some shell command for node.js. And so this was all about how we create TCP socket and communicate between the client and server. Okay, so now we are done with the socket programming. So the socket has been created and we can transfer TCP packets from one from client to the server. So basically, for the transport layer, we are done. The transport layer is set up. Now we have to set up the protocol of our own HTTPR, and let's see how we can do that. So for that, and we have to enable our protocol to be working from the browser also. So for if it has to work from the browser, it should work with Node.js, and this is the most important thing that we will be doing now. So we'll create another directory for the uh, applications, and in the applications we will be having a server.js and client.js. We have this server which will be up and running continuously. The only difference is that we have to, whenever we send request from the client will have to establish a connection with the server, send the data that it has to obtain the response, and once the response is obtained, we can close this connection. So this is what we are going to implement. We will have to have our own set of rules that the client and server will agree to. Yes. So now let's create a module named HTTPR. In the HTTPR, let's create an httpr.js file, add a function to it that would be, let's say, httpr, consisting of, it will take two arguments. One would be the endpoint and another would be the request body, let's say, or else just the body. And once you have the endpoint and body, we can now figure out how this can be done. I'll just port this towards HTTPR. Okay, so we are building this for the client side. The client will send some request to the server, and the server will then execute the function based upon that. Okay, so let's build this. Okay, so let's create this function HTTPR. What this function will do is it will get the endpoint, it will determine what function it has to execute, and also it will send the arguments that are present in the body. So this is the basic thing that we have to do now, and it's 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 just the basis of how the protocol is going to be. There can be many complex attributes that we can associate with this protocol. But currently, let's try implementing this one, and then later on we can think of any complex attributes. So first of all, let's say how will our endpoint look like? So our endpoint will look like. mm, okay, so let's keep it this way: httpr/host, that is 127.0.0.1, and uh, and the function that we want to execute. Yeah, so this is the endpoint, and also we'll be sending the body with it, which will be different. Okay, so let's keep it that way. First of all, what we will do is let's split this up. Let's extract the host out of this endpoint so that we will split it and get the second element. Then here we are assuming that any endpoint that will be hit on to this function will be of the type HTTPS, or else we can also have it check over here with endpoint dot split slash of 0 is not equal to, let's say, HTTPR. If it's not equal to HTTPR, we can simply return from this function and just spit out that error. And if not, we can get the host, then we can get the function call, and also we have the request body. So R argument. Oh, yes. So now we just have to send all of this to the server. So, okay, so let's not parse the body. Let's keep the body as it is. We will parse it out on the other end. We have the function call and the host, which is important on the server side. So we just have to send this information to the server. So we have the host. We just have to send the function call and the body to the server. So for that, uh, what we need to do is we need to invoke the client.cpp. We need to establish a connection with the server.cpp and send data to the server. Okay, so for that, we will execute some shell script which will consist of, we also put two arguments. One would be the host, another would be the function call, and the third one would be body. So this is what we will be doing, and let's see if we get some std out or the error console.log std out. Okay, so that looks fine. And on the client.js, I'll have to call this function. So first of all, I'll import this httpr. we will get some std out here, and I'll just create a response. We will set the response as std out and return response, and just log. Okay, so this should work. And in the httpr.js, we have this this function that executes the command. We will also have to make some changes to the client.cpp. We'll have to get these arguments, and these arguments will be placed over here. So, uh, so let's make changes to the CPP file that we have. We'll have to set the argument count and the argument vector. Uh, so that would be char star argv. We have the argument count and the argument vector. So once we have that, we will just extract all the information that we want. Okay, so maybe the function is something that we don't have to deal with. The function is something that the uh, the server will deal with the function. I don't have to care about it. So let's create another object over here. We have passed the endpoint and body. I will create another object of request that consists of endpoint as well as the body. So I will not pass this function over here. I'll just pass the request. Let's say JSON dot stringify request is something that we will be passing. And yeah, so that looks fine. We're passing the request string, and on the other hand, we want this to be host. Along with that, mm, that now that looks fine. And the other part is the request. Send and receive to server. Here we will be sending this request as well. So that will be done. Now, once the request is obtained on server.cpp, we have to send this request to server.js. Okay, so we read the buffer and we get the buffer output. Now we need to send it to Node.js. On the server.js, we will be having a main function that is going to execute. In the main function, we will do something. And okay, so let's see how it goes. Mm, Create a command string equals this plus request and just command dot type. So these things should work. And now we also have to access the uh, arguments from the shell at the node side. Okay, so yes, so here we can access it like process dot argv. Okay, okay, so here the arguments start from 0 and we can access it on the server.js side. on the server.js side, I'll just print the request. So I'm sorry, that log process dot agree. Okay, so try this. Let's try this. Compiling the server, compiling the client as well, and the server has started. Now, yes, so do we have anything in the client? Yeah, we have something in the client. We'll execute this. And yes, the location of our file was wrong. Okay, so the endpoint that we are passing is not right. Fine. The endpoint that we are passing is add, which is wrong. 97.0.0.1 slash add. Right. That should work now. Since error exec is not defined, this we have to include this. So there is something that is working and something that is not working as well. Problem here is that we can see that there was some infinite loop because of which everything was reprinting again and again. So we just have to remove this infinite loop from here so that we can execute it well. And let's return to format the document. Yeah, so that looks fine. Now if I send this to the client, to the server, I'll just start the server once and manually send something to the client. Okay, so it's printing multiple times. Okay, okay. So this works now. It works fine. We got this from the client, and the client has responded, and the server has responded as well. Okay, so it created connected to server socket. Okay, so what I feel here is the problem would be that the exec command that we are executing is from this path, that is from the socket directory, and maybe this relative part doesn't work for this thing. So that is why maybe I'll just try putting the absolute path in all files, and then let's see how if it works, then that would be good. But if not, then see what we can do about it. Yes, so some part of it is fixed because I can see now that these characters are being printed, although the entire request is not getting printed. The reason might be because of the fact that I had set it to size of request.pstr. So this actually is a pointer, and that pointer is just of 8 bytes. So that is why it was printing 8 bytes only. But now that we have the entire thing, it should actually do it well. So the body is in the form of a string, which I want. I just send it straight away. Endpoint and body to httpr.js. Here we create the request, body and function call, and then we executing. So that would do. So now it is printing fine, but there is some problem with the size of the buffer that we are reading. It is creating an issue. So let's do one thing. Let's not keep it as the size of request. Let's keep it as request dot length. Yeah, fine. So that works now. Let's do that with Node. This works with Node as well. And so once we have it on the further path, we will just print the request body that we have opted. Okay, so let's do that. Okay, so we can just straight away get this the out of the if statement, and we can simply exit after this read. So read is a blocking function. So anyways, it is going to block the code until it reads something from the server. Once we read it from the server, we can simply add this close function, and we can close the socket forever. So yeah, that can be done. But let's see how we can proceed with that later on. Now the more important thing is that we need to execute this node command, and so is the path of node. Okay, so 0 is the path of node, so we'll have to have 1 give us the path of this file that we are executing. And okay, so we don't have the entire string of this request body. For that, we will have to send this string. Okay, so this works now. We have the command that we are executing, and the command is executing fine. On the server side, we have the request object entirely, and this request object, now we can play with this request object as how we require. So, and to JSON. False. Okay, and now we can access this request object. We will out of this response. So first of all, we okay. So if the function call is add, we perform this function. Okay, so this is something that we have obtained at the server. Now this we'll have to write this back to the client and close the connection. Okay, so let's see if that works. Okay, so the problem that we are facing now is that the JSON format, the JSON string that we are receiving is not of the format that we want, and the Node.js code is unable to parse it. So first we will have to convert this into a valid JSON format and then parse it using JSON.parse, and then we can use it. So for that, first of all, so we'll be using a regular expression over here. So basically, we just have to find out the pattern of, let's say, of any form like string and colon. So we just have to find this kind of pattern, and we will replace this uh, with double quotes, string and colon. So this is what we got to do. So let's try this using regular expression. So what I'll do is str equals str dot replace. Uh, let's find the patterns out over here. So we'll so that should convert it into a valid JSON format. Once we get to a valid JSON format, we can then parse it. Let's see if that works. Okay, so we have added these two regular expressions so that we can convert it into a valid JSON string. Once we get it into a valid JSON string, we can pass this request argument, also also add, also determine what function we have to implement, and the function can then be executed to get the final response. Now we also have to send this. Okay, so first let's test this out if that works. Okay, so yeah, so that works. Mm, Now we just have to capture this response and then we can send it back to the client. So let's do that. So dot learn JSON dot stringify response. We'll have to find some way to capture whatever we are printing onto the command line. For that, maybe we can use a pipe and that will help us to do that. Mm, Okay, so we have this thing, we can use pipe. So we won't be using the system command, we will straight away use a pipe and then get the response. So let's try doing this. Mm, Okay, so this should work. Okay, fine. So we have this as success, and in the result, we have so everything that we had logged has come up in the result. So we will just remove the console.log statements. Mm, so response is something that we want, and we don't want this as well. So yeah, that works. We have the result now, I guess. And let's also comment this out. Exit failure. Never mind. Just keep it as it is for now. Okay, so this socket TCP socket server is running, and now we will just start the node application. So from the client of the Node.js application, we are trying to send a request and we are expecting a response. So yeah, so this is fine, and we get the response. As you can see, data is 3, response is null, and status is success. So there is some issue here as well, I feel like. Hmm, data and status. Fine. So we will, okay, so if we don't set this, it doesn't matter. So let's not do that here. Response will be set. Now the response is being obtained at the server side. Once we get it, we also need to send this. So through that result dot length, send it to the client. Once the client reads it, we will have to send it to main again. Right. So for that, so we have read this from the client. Now here, send std out as response, buffer that is obtained. So we'll have to do something for this. After reading, we'll perform some operation that we want to, and then we can just close the socket file descriptor from the client side. Yeah, so we will just close it, and fine, that is fine. Now I'll just see if the buffer that is being obtained is correct. So I think that it is entering into an infinite loop. Yes, so now this is working fine. Hmm, means that the problem is with this write connection. Okay, so now anyways, the problem that we have is even if we try to persist the server socket, we won't be able to connect more sockets to it. So for that, we might have to use some different technology. But currently, we can't do that. So what we have done is after writing to the client socket, we will just break out and the program will end as well as the client will get the response. Now, yes, so the problem that we got to solve now is that the response we are getting is undefined here. So for that, we will have to do something. Okay, so basically we have implemented the whole thing, but the only thing that is not working is the response that we are getting is not being displayed on the client.js. It is working with client.cpp. The response that we are getting from the server is correct. And if we see out the buffer over here, the buffer that we are obtaining is this one, and it is appearing to be correct. But on the client.js side, I'm unable to get this response out from the standard output that you are getting, and then the response that I'm receiving is coming to be undefined. So this is the only problem that I'm facing now, and mm, yeah, I'm not able to find a solution to this. I don't know. There is some mistake that I'm making, but obviously that's not something that I'm able to figure out. So yeah, so let's see how this is working overall. So let's get into two different terminals. One would be the client. Okay, okay, so these are the two terminals for us. We will first start the server. For server, I'll just compile these ones. Just compiling the server and client once again. And now let's start the server. The server is listening. Now let's run the client code. So, okay, so this is undefined, but we are getting a result over here. And now let's go one layer deeper down and let's check that if our client.cpp is running fine. So for that, what we can do is we can straight away uh, hit on to the client.cpp. So first of all, let's turn the server on. Let now this is the client .cpp that we had built. This is the host name that we are providing, and also the data, that is the request body that we are providing. So yeah, so the client is working fine. We are getting this data correctly. The buffer that we're obtaining is correct, and after this it is also closing the connection, so that is fine. What we can do here is we can again on the client side, once we get this data, once we read it from here, once we get the buffer, we can again write and we can send some flag that would act as an acknowledgement. Once this acknowledgement is obtained at the server side, we can then close the connection, not for socket file descriptor. We want this connection to persist. So that is why we won't disconnect the socket, but we can disconnect the connection file descriptor and again start listening, and then we can again accept from the client whenever another client connects, or the same client connects, or anything of that sort. So that can be done. So for that, basically, we'll have to just send an acknowledgement, and then we can accept that we can check that acknowledgement here, disconnect, and then accept for be ready for newer connections. So this is how basically we have implemented the protocol that we had built. So our protocol is a very basic protocol. So if we just create an analogy with our HTTP protocol, so so we have a server.js that we build every time when we create an application, a web application that works on HTTP. So in this we have a response object, and we have seen in Express that there is a request and response object. Similarly, we have a response object here which can be passed by JSON. And so these are the different function calls. So if you look at Express in HTTP, there are different types of requests that you can make. Some there are get requests and post requests, and you have post request as well. So there are these different types of requests that we can send. Although these don't have different functions as such, not a lot. It's just meant to, you know, meant for understanding that. Okay, so these are different ways in which you can send requests. So in the same way, we have created these function calls. Uh, okay, so these are acting as routes in our design. So if you look at this, we have an add function. If we change it to subtract, it will give some different. It will execute the subtract function. So these are the routes that we can implement. It's like routing in Express, and then you send the response status and response data. Then this response can then be taken up by the client. So yeah, so this is how basically we can create our own protocol. The important thing that we make out of this is that once we have a TCP socket layer, a TCP socket established between the transport layer, then there is no way we can transfer data in any way that you want to, and that simply will be your protocol. So HTTP is a very robust protocol, a very a very stable protocol agreed by everybody, and it's a protocol that is standardized and everybody has accepted that standard. So we are following that protocol. We can create our own protocol as well. Obviously, it will take a lot of effort and it will obviously have a lot of complexities that we might not understand, and it will take years for it to be stable, for it to get stable and uh, be a reliable protocol. So basically, this is how we can implement things. And apart from this shell script, so shell script is something that we are executing now just to implement this protocol thing. But in real time, we in real scenarios, we can use WebAssembly. So as I had already mentioned, WebAssembly is something that allows us to handle very low level programming of an application. So if you look at this client.js, okay, so let's look at server.js. So in client.js, what we are doing is we are executing this function. So this is a shell script. Rather than executing this function in a different shell as a child process, we can simply export a function from server.cpp or client.cpp, whichever is required, and we can simply execute that function over here. So that is something that WebAssembly provides us. So there, if you can search for mscript10. So mscript10 is something that provides an API uh, for us to execute C++ or C or any low level programming code in the JavaScript environment or in a browser environment. So basically, the browser can have a deeper access to the hardware and a deeper access to system calls, which can help us create some better protocols and better standards for the for which can have many different use cases in our life. So yeah, that was how everything was built, and that's it from my side for now. And thank you.